Welcome to our video on loan approval prediction using machine learning. In this video, we'll explore how machine learning models can help predict whether a loan application will be approved or not. We'll cover the basics of the problem, the data needed, and the types of models typically used, along with a step-by-step guide on how to build your own loan prediction model. Whether you're a data science enthusiast or someone interested in financial technology, this video will give you valuable insights into using machine learning for loan approval prediction. First, let's understand the problem. Loan approval is a crucial decision for financial institutions, and it involves assessing whether an applicant is likely to repay the loan. Traditionally, loan officers would manually evaluate applications based on factors like income, employment, credit history, and more. But with advances in machine learning, banks and financial companies are now using AI to automate this process, making it faster and more accurate. Machine learning models can analyze vast amounts of data, learn from historical patterns, and make predictions that help institutions manage risk more effectively. The key to building a loan approval prediction system is having the right data. Typical features used in this type of model include applicant income, credit score, loan amount, employment status, and the applicant's debt-to-income ratio. The data is used to train a machine learning model, which learns to identify patterns associated with approved and rejected loans. The more comprehensive and clean the dataset, the better the model's performance will be. It's also important to consider the quality of data. Any errors or missing values can negatively impact the model's ability to make accurate predictions. Let's dive into the steps involved in building a loan approval prediction model. The first step is data collection and preprocessing. You'll need a dataset that contains information about past loan applicants and their outcomes, whether their loan was approved or not. Once you have the dataset, it's important to preprocess it by handling missing values, normalizing numerical features, and encoding categorical variables. Data preprocessing is a crucial step, as it ensures that the model can learn effectively without being hindered by inconsistencies in the data. Handling missing values can involve techniques like mean imputation or using models to predict missing entries, while encoding categorical variables involves transforming non-numerical data into a numerical format. Next, we move on to feature selection. Not all features are equally important for predicting loan approval. For example, an applicant's credit score may have a much bigger impact on the decision compared to their marital status. Using techniques like feature importance scores, correlation analysis, or even dimensionality reduction methods like principal component analysis, PCA, you can identify which features are the most relevant for the model. This step helps in reducing the complexity of the model and improves its accuracy by focusing on the most informative variables. Once the data is ready, it's time to choose a machine learning algorithm. Common algorithms used for loan approval prediction include logistic regression, decision trees, random forests, and gradient boosting. Logistic regression is a good starting point because it's simple and interpretable, making it easy to understand the relationship between input features and the output. Decision trees, on the other hand, are more powerful and can capture complex relationships in the data. Random forests, which are ensembles of decision trees, provide better generalization and accuracy. Gradient boosting algorithms like XGBoost are often used for their high accuracy, especially in cases where there are many features and nonlinear relationships between them. After selecting the algorithm, the next step is to train the model. The dataset is split into training and testing sets, typically with 70–80% of the data used for training and the rest for testing. During training, the model learns the relationships between input features and the target variable, whether the loan is approved or not. The testing set is used to evaluate how well the model generalizes to new, unseen data. Metrics like accuracy, precision, recall, and F1 score are used to assess the performance of the model, ensuring that it makes reliable predictions. Precision and recall are particularly important in loan approval, as they help understand the balance between false approvals and false rejections. An important aspect of machine learning models is avoiding overfitting. Overfitting happens when the model learns the training data too well, including noise and irrelevant patterns, which makes it perform poorly on new data. Techniques like cross-validation, regularization, such as L1 or L2 regularization, and pruning, for decision trees, can help prevent overfitting, ensuring that the model remains robust and performs well in real-world scenarios. Cross-validation involves splitting the training data into multiple parts and training the model multiple times to ensure it generalizes well. Once the model is trained and evaluated, it can be deployed to make real-time predictions. For instance, when a new loan application comes in, the model can analyze the applicant's data and predict the likelihood of approval within seconds. This can significantly speed up the decision-making process and reduce the workload for human loan officers, allowing them to focus on more complex cases that require human judgment. The deployment process can involve integrating the model into a web application or API, allowing loan officers or customers to interact with the system directly. Loan approval prediction models also come with challenges. One major challenge is ensuring fairness and avoiding bias. Machine learning models learn from historical data, which may contain biases, such as discrimination based on race, gender, or income. If these biases are present in the data, the model may inadvertently learn to discriminate, leading to unfair outcomes. It's important to regularly audit the model and use fairness metrics to ensure that the predictions are not biased against any particular group. By taking steps to identify and mitigate bias, financial institutions can ensure that their AI systems are equitable and uphold ethical standards. Techniques such as adversarial debiasing and fairness-aware learning can be used to help reduce bias in the model. Another challenge is handling imbalanced data. In many cases, the number of approved loans far outweighs the number of rejected ones, which can lead to models that are biased towards approval. Techniques like oversampling the minority class, undersampling the majority class, or using algorithms like SMOT, synthetic minority oversampling technique, can help address this issue and improve the model's ability to accurately predict both approvals and rejections. Balancing the data ensures that the model doesn't simply learn to predict the majority class, but instead gives equal consideration to both approved and rejected cases. Monitoring and maintenance are also crucial once the model is deployed. The data used for predictions can change over time, a phenomenon known as data drift. Regularly monitoring the model's performance and retraining it with new data helps ensure that it remains accurate and relevant. This is especially important in financial applications, where changes in economic conditions or customer behavior can impact the effectiveness of the model. Setting up a pipeline for continuous evaluation and retraining can help keep the model up to date. One of the practical considerations in loan approval prediction is model interpretability. Financial institutions need to understand why a model makes a certain prediction, especially when it comes to rejecting an application. Models like logistic regression and decision trees are easier to interpret, but more complex models like random forests or gradient boosting can be more challenging. Using tools like Shapley additive explanations, or LINE, local interpretable model agnostic explanations, can help provide insights into model decisions, ensuring transparency and building trust with both regulators and applicants. In conclusion, loan approval prediction using machine learning is a powerful application of AI that can help financial institutions streamline their processes and make more informed decisions. By using data to train models, banks can evaluate loan applications quickly, efficiently, and with greater accuracy. However, building a reliable loan prediction model requires careful attention to data quality, fairness, robustness, and interpretability to ensure that the system is both accurate and ethical. Addressing challenges like bias, data imbalance, data drift, and ensuring transparency is key to building trustworthy AI systems that benefit both financial institutions and applicants. Thank you for watching this guide on loan approval prediction using machine learning. If you found this video helpful, please like, share, and subscribe for more AI content and tutorials. Let us know in the comments, what do you think about using AI for financial decision-making? Would you trust an AI to evaluate your loan application? We'd love to hear your thoughts and experiences with AI in the financial sector.